This is TWIS. This Week in Science, episode number 593, recorded on Wednesday, November 16th, 2016. Tickling Your Science Bone. Hey everyone, I am Dr. Kiki, and we are here today to fill your heads with a pig personality, rat giggles, and coffee. But first...
Disclaimer, disclaimer, disclaimer. There is a difference between what we want to see in this world and what we sometimes get. Reality, it seems, is a result-oriented endeavor. There are moments in time when we can affect change, moments when we can simply observe the results of change, and moments in which we are changed by a result. When change is heading your way, as it often does, you have two basic choices to make. Let that change affect you, or change your affect. If you change the way you interact with reality, knowing that it is a result-oriented endeavor, the world you want to see can be the result you made happen. And sometimes, that can make all the difference in the world. And what better result of reality could there be than This Week in Science? Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Science to you, Kiki and Blair.
And a good science to you, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back yet again to science it up. We brought all sorts of stories, all sorts of fun discussion about, what's happening in the world. What are people discovering? What are the cool new discoveries? Let's talk about them. Let's discover them for ourselves. Oh, and just so you know, This Week in Science has the 2017 Blair's Animal Corner calendar on the way. So make sure you go to TWIS.org if you're interested in finding out more about that. Also, if you love TWIS, share us with your friends on social media. We know you have the Twitters and the Facebookas as...
Facebook.
Yeah, as Blair likes to call it. Yes. It's not Italian. It's just the Facebook or the Instagrams or the Snapchats or whatever it is. Share us with your friends. Tell other people they should be listening to us or watching us as well. That would be awesome. Now, on to the show. We have all sorts of science news. I have stories about the end of the world. Dun, dun, dun! It's coming. Rat brains and coffee, because you got to drink coffee to watch the end of the world happen, right? Justin.
I want to sleep through that.
No, Justin, what do you have?
I've got, what do I have? I have talking microbes, human antibiotics, and underwater archaeology.
Blurp, 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 blurp. And Blair, what's happening in the animal corner?
I have moody pigs, cockatoos that are good at building tools, and very fast animals and very, very savage animals. I have lots going on today. It's kind of all over the map.
Sorry, I'm giggling at cockatools.
Cockatools. Oh, man. Missed opportunity.
Justin knew I was going there.
Can I just rewind? I have moody pigs and cockatools today.
There we go.
See, we'll fix it in post. It's fine.
It's fine. All right, let's jump into it, everybody. It looks like it's going to be an awesome show. I hope you're ready for the next hour or so to listen, learn, and discuss some more. All right, first up, this is super awesome. We've been talking about CRISPR for a long time and whether or not it's actually going to be tested in people. And, there's ethical questions about editing cells and then using them in people. But, here in the United States, we don't live in China yet. Anyway. Chinese scientists are moving forward with a CRISPR-Cas9 gene editing technique to treat patients with lung cancer, aggressive lung cancer. This is a clinical trial. It's more of like a safety efficacy study. So they're only looking at about 10 patients at the West China Hospital in Chengdu. So this is led by oncologist Lu Yu at Sichuan University in Chengdu, and they have delivered altered cells to their first patient. The report says. So on October 28th, basically what they did is they took immune cells from the blood of the patient with a form of very aggressive lung cancer. And then they took the cells, isolated them in a dish, applied the CRISPR-Cas9 technique to alter a gene related to immune system function. And part of the way this gene works, it codes for a protein called PD-1. And normally this stops a cell's, it stops a cell's immune response. And it affects a cell's ability to proliferate. And so when it's disabled, the proliferation is changed and cancers take advantage of it. And so basically what they've done is they've cut out this gene that codes for the disabled PD-1. So
got rid of the back door.
Exactly. And then they took the cells and they multiplied them. So they only had a few from the blood of the patient at first. They multiplied them, and then they took them and they put it back into the patient. So there's no worry of rejection. This is a patient's own cells, only slightly edited. And the hope is that now that this gene that really isn't working to stop cell proliferation, that without it, these cells are going to basically attack and kill the cancer, keep them from the cells from proliferating.
That's awesome.
Yeah, so we have to wait and see. This is, like I said, again, kind of a safety trial. They've done previous studies. I mean, they've moved forward to this human study because they have done prior animal work. And now they're going to be monitoring the patients for 6 months to see whether injections cause serious adverse effects or whether or not there's any benefit, whether or not the cancer starts going away, goes into remission. So this is pretty exciting. And this is the first real human trial of a CRISPR technique.
That's fantastic. And is it, I mean, I don't know if this is just because this is where this research was being done, but is there a strict moratorium on doing anything like this in the U.S.?
Yes and no. Yeah. I mean, this has been kind of, there's been a global moratorium on doing human gene editing studies. But then last year we talked about a group of researchers and policymakers coming together to discuss the effects of various kinds of research into CRISPR-Cas9 and how gene editing can affect humans. And I mean, the big ethical questions we've talked about before are when edits can get into the germline or the reproductive cells. And so this particular therapy is not something that would affect the reproductive cells. This would not be passed on down the lineage. And so there's no worry of, having edited humans being born.
And right. So, and we've talked, I mean, I know the research is definitely underway here. The research
and so we're actually, there is research that's supposed to be starting here in the United States in 2017, hopefully. There's a trial from that's going to be using CRISPR to target 3 genes with the goal of treating different kinds of cancer. So a very similar idea, using CRISPR-Cas9 to edit and remove various genes for various types of cancer. And so that's supposed to start in the United States in 2017. So it just hasn't happened yet. There are other researchers, also a group in Peking University in Beijing is hoping to start clinical trials using CRISPR against bladder, prostate, and renal cell cancers, but they haven't yet gotten approval or funding. So it's on the move. Human studies are making headway. They're getting approval by the various review and approval boards to move into human trials, which is very exciting.
Do it, do it, do it.
Yeah. So anyway, it's pretty cool. We'll wait and see what happens with this Chinese trial. And, very similarly, a few more in 2017 potentially getting started to also treat cancers. And so we'll see how CRISPR-Cas9 does in this paradigm for cancer therapy. It's very exciting. Yeah, and so then moving on from cancer, let's get to the end of the world. So we all know that the humans have given the planet Earth a nice case of chlamydia. Right?
Chlamydia, yes.
Chlamydia, yes, we've done it. So anyway, we've been trying to be better and, treat the Earth a little bit better. And there's good news. I'm going to start with the good news. The Earth, our global carbon dioxide emissions have been flat for the third year in a row. And so the Global Carbon Project, who measure how much carbon dioxide humans emit every year, they also measure how much gets absorbed by various sinks, biomass sinks, the ocean, plants, land surfaces, etc. Basically figure out how much carbon dioxide is going into the atmosphere to drive global warming. And they say, third year in a row, there's only about a 0.2% increase above emissions of level of 2015. Barely. It's really kind of within the error bars. So it's flat, no increase. Good job, people.
So yeah, to an extent.
Yeah, but I have other things to say about this. So
sure. My analogy of this is, for the last 3 years, the world has put on a credit card the same amount more than it earns or could pay off in that year. So while we're not increasing our reliance on the carbon credit card, we're still putting more on it than we can pay off. If that makes any sense.
Well, I would say this is good news, though, because there's some countries out there who are still increasing their carbon output. So this means, mathematically, some countries have started going in the negative.
No.
No?
No. Nobody's going in the negative. We're flat, which is good.
Well, I'm just saying it's averaging to flat because there's probably some countries that are doing more than they were before, but that means some countries are doing less than they were before. That's more what I meant. So, some countries have figured out how to slow down, and we're slowly ramping down how much carbon dioxide, at least for some countries. So I would say that's inspiring.
Yes,
because some countries are having economic slowdowns at the moment.
Right. So there have been exactly.
That's a good thing, really. I mean,
so here's the deal: the United States and China have been curbing their coal reliance, and that is a huge part of reducing the amount of carbon dioxide that the United States and China, two of the top producers in the world, put into the atmosphere. Now, an organization putting together the Climate Change Performance Index of 2017 reported on around the UN climate talks that were taking place in Marrakesh during the last week, and they found absolutely no country is shifting to clean energy fast enough or reducing their reliance on coal or petroleum products fast enough to keep global warming below 2 degrees Celsius. Mm-hmm. They ranked 58 nations responsible for 90% of the energy-related CO2 emissions. They find France is being awesome. So, they're part of the Paris Agreement that we signed last year. France is number one. But they rely a lot on nuclear power, right? So that's one aspect. we also have Sweden and Britain, silver and bronze, because they had some cool policies that were put in place. But oh, hey, look, those governments aren't in power anymore. So we'll see what happens there. And then, yeah, the United States and China not doing so well. United States, the second largest greenhouse gas emitter in the world after China, lost ground across all categories. We also have Canada, Australia, and Japan at the bottom of the ranking. So we have a lot of work. Basically, falling oil prices, according to Jan Burke of German Watch, who's the lead author of the report. Falling oil prices did not cause an increase in demand for the energy source, while a growing number of countries are starting to turn their back on coal. So this is good. There is a growth in renewables, even though it's not enough. So the point here is we still have a lot more work to do in terms of renewables. And why really do we need to move on this to keep the 2-degree temperature increase down globally? Well, like I said, we had flat growth in carbon dioxide emissions globally, so no growth necessarily, but that's emissions. The amount of carbon dioxide in the atmosphere is at a record high again. And so the researchers looking into it say that last year, 2015, it was a record high and could again be in 2016. Atmospheric CO2 levels exceeded 400 parts per million in 2015. And these carbon dioxide levels are linked to temperature. 2015 did see the El Nino event that lasted from May 2015 to June 2016 this year. And so that reduced the amount of biomass, land mass, because it was hotter and wetter, or actually it was hotter and drier over tropical land, reduced the amount of biomass that was available to act as a carbon sink. So there was, because of El Nino, those hot, dry conditions kept the carbon from being able to be put away. So potentially we're going to be in La Nina this year. We actually are in La Nina now. Lots of rain, going to be cold, 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 wet, wet. Maybe we'll be a better carbon sink from this part of 2016 into 2017. We don't know, but still, there are weather pattern fluctuations that change how carbon can be put away and stored by the planet. But at the same time, we need to, like Justin said, stop using the credit card.
Mm-hmm. Yeah. And there's also, to put a last bit of perspective on this, energy consumption, at least like when you look at oil, it goes up a magnitude every 10 years, which means what we use from, say, 2000 to 2010 was as much as we had ever used before combined. Right. It's the same amount, right? And as that goes, it's always gone that way backwards in time if you look at it. So even sustaining this level, even if we continued not to change, we're still in 10 years going to use as much oil and put out as much of these carbons and use as much energy as we did in all of the years starting in the Industrial Revolution, right? Like way back then, all of that combined every 10 years. And we're experiencing the climate change of almost 50 years ago, because this is the carbon sink cycle of the ocean. So it's gonna be a wild ride for a while. There's no getting off of this. But what we're doing and attempting to do now is make sure our children's children have a world that they can live in.
Yeah, it's time to start thinking about the future and not just thinking about ourselves. So anyway, it's the end of the world as we know it. I'm buckling my seatbelt. My arms go up. Woo! I feel fine. No, I don't. No, I don't. All right, Justin, what you got for us?
How do you know an evolutionary trait is useful?
Because it's there.
Because it's there. It's conserved over a great span of time, right?
But sometimes there are things that are weird. What are
That's
they
true.
doing there?
I mean, I guess, yeah, if they're there, you just know that they're not terribly detrimental.
Yes, there's that. In the case of Akkermansia mucinifila, its survival is as much due to its traits as it is to the evolutionary benefit it provides to others. And as the name might have tipped you off, Akkermansia mucinifila, or fila, is a bacteria. Researchers at Oregon State University have discovered how it functions in the gut in helping to regulate glucose metabolism. This bacteria's function is so important, scientists say, that it has been conserved through millions of years of evolution to perform a similar function in both mice and humans. So this is, they say this is, it's got this same sort of symbiotic relationship with mouse and human. Could be even beyond millions of years. This might mean this has been around since an ancient ancestor. Yeah.
I'm going to go out on a limb here.
Mm-hmm.
Mucinifila, like mucus loving. It's a mucus loving bacteria.
Yeah. Part of why this is such a fascinating, interesting thing is not only that they're realizing it helps to regulate glucose and metabolism, but because this particular bacteria can talk.
What?
Quotey voice. This is Dr. Natalia Shulzenko, assistant professor at Oregon State. We're discovering that in biology there are multiple connections and communications, what we call crosstalk. They're very important in ways we're just beginning to understand. It's being made clear by a number of studies that our immune system in particular is closely linked to other metabolic functions in ways we never realized. This is still unconventional thinking, and it's being described as a new field called immune metabolism. Through the process of evolution, mammals, including humans, have developed functional systems that communicate with each other, and microbes are an essential part of that process. So if the crosstalk and interaction with A. mucinifila are disrupted, it can lead to type 2 diabetes and metabolic syndrome. It does an important link between the immune system, gut bacteria, and glucose metabolism. Cross-talk interaction that can lead to that type 2 diabetes when not functioning properly. So again, this is just another layer of understanding how bacteria are really kind of running stuff and a really integral part of our immune system. May lead to another way of looking at type 2 diabetes. This could be another drill down now that they've sort of discovered that this crosstalk, when it's interrupted, was leading to type 2 diabetes in their tests. It's possible that there's some cases of type 2 diabetes that you could maybe source down to this bacteria. Now, it's not the only bacteria in this chain. It's sort of a community, but they've isolated this one and its one function is being part of it.
Yeah, or maybe it's the ecosystem or the environment of the gut that changes, and the bacteria for some reason it can't live there anymore, and then that you lose it, and then maybe that leads to the type 2 diabetes.
Yeah. And so those observations were made in mice. They say similar observations were also made in humans. It's been observed, for instance, that athletes who are extremely fit have high levels of the gut bacteria A. mucinifila, which is, there you go, a mucus-degrading bacteria. The research makes it clear that two systems...
I love it. I'm going to eat it.
Once believed to be functionally separate, immunity and glucose metabolism are, in fact, closely linked. And what bridges that difference between the two may be that gut bacteria. There's probably more than one bacteria involved, they go on, in this process of communication and metabolic control. The gut harbors literally thousands of microbes that appear to function almost as metabolically active organ. That's an interesting way. The ecosystem, but thinking of your gut bacteria as a separate organ, like you would identify your heart, your lungs, your liver, your microbiota, are in a sense, as they're saying here, perhaps can be looked at as an organ. Wow, that's an interesting way of looking at it, right?
That's fascinating, yeah.
Bacteria-mediated communication, of course, is just one part of complex human system. Issues such as proper diet, exercise, appropriate weight control is still important, research has said. But as we all know, with a single order of Dr. Justin's not a real doctor, poop pills, you can cure almost anything.
No, I thought the idea that you could think of the bacteria as an active organ, I think is fascinating. I don't know that that necessarily in itself is accurate, though. I think it would be more that this is a level of each of the organs, the stomach, in the gastrointestinal tract that we have not taken into account. It's a different tissue layer, the bacterial layer.
Because you're going to say the stomach is an organ already.
It is an organ.
Yeah.
Yeah, the stomach, your small intestine, your large intestine.
Part of what the gastrointestinal system organ,
Your esophagus.
how it functions is.
Yeah. Yeah. But yeah, this is fascinating. Oh, bacteria, how many, let us count the ways that we love you. It's fascinating. If you just tuned in, you are with TWIS. You know what time it is, though?
What time is it?
It's time for Blair's Animal Corner.
She loves our creatures, crab and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels.
What you got, Blair?
I have yet another case of an animal making tools. This individual story is interesting for some very specific reasons, though. This bit of research from the University of Veterinary Medicine in Vienna and the University of Oxford, we're looking at Goffin's cockatoos and their ability to make tools. Why this is interesting is that the hypothesis behind the making of tools, not just the use of tools, but being able to fabricate tools, is that it is some sort of combination of heritable and acquired competencies with tools. So there has to be either or and
Okay.
yes, some combo of heritable traits, so something that is passed through the bloodline of the ability and the kind of predisposition to make tools, some combination of that, and then being able to learn from one another, acquired abilities. So if it's heavy on one side, you need less of the other side. So there has to be some combination of these two items.
Right.
The cockatoo, this cockatoo in particular is interesting, is not known for tool use, nor the ability to make tools. So in the wild, these guys don't use tools at all. But these cockatoos in a lab have been shown to use tools and make tools. So that means it's something that they can think through and do. This isn't something that they watched another cockatoo do and then they do it. It's something that they have a problem in front of them and they make a tool and they fix that problem. So the test that they had for these birds was to, they had kind of a glass box and there was food placed a few centimeters,
Centimeters. I like
centimeters behind a circular hole in that clear box. And the piece of food was kind of on a pedestal. And Kiki, I'm wondering if you'll be able to bring up this video. Perhaps.
I am going to bring up this video.
That's fantastic. So
Gotcha.
The food is on this pedestal through this hole. And then if the food is pushed off the pedestal, it will slide down a slanted floor of this box and it will come out under the front. So basically they have to knock this little piece of food off of a pedestal by pushing through this circular hole. So how do you do that? You do that with some sort of stick. So these cockatoos were given 4 different materials to see if they could make something to fix this problem. Larchwood, which is something that they already had in their kind of repertoire. Leafy beech twigs, which were not in any way, shape, or form something that they could use at the start. Cardboard, and amorphous beeswax. That last one just seems cruel. So what they did,
have this smushy thing that you could and see what you could do with it.
So what's so interesting, we're watching in the video right now, is that with the larch wood, they were able to bite at it just a couple of times and then pull. And because of the way the wood fibers work, they pulled off a stick. And they were able to use that stick to knock the food off of the pedestal and get the food. So that was fairly easy. They just kind of bit at it, and it happened by nature of that thing. The beech branch, they had to pull individual leaves off of, and then they were able to use it as a stick. Where it gets very interesting is the cardboard, because it is in no way, shape, or form anything, if you were to look at it, like something that could help them accomplish this task. But what they did is they actually kind of punched holes in the cardboard, and then they were able to pull it apart into a long, thin shape, basically making a flat twig. So they were able to make the tool that they needed out of all of these different materials. Of course, with the amorphous beeswax, nobody could do it. What are you going to do with that?
You wouldn't expect them to anyway. What do I do with this?
So the fascinating thing here is they made similar items out of 3 different materials, which means they had something in mind that would solve their problem. So what they're trying to figure out is how these animals are thinking. Are they imagining a stick in their mind? Does that image show up as a template? Or is there something else that's causing them to make this shape?
Yeah, well, I wonder, I haven't read this particular study, but I wonder, I'd hope that with their animals, they didn't always give them those particular materials in that order, right, and that they were randomly assigned different materials in different orders so that they would just de novo come up with the solutions,
right,
as opposed to, oh, look, I made a stick out of this wood and it worked really easily. Oh, look, I took the leaves off of the twig and then it worked really easily. I'll do the same with the cardboard,
Yes, absolutely. And one would hope that that's how they did that, because that would be good science. As far as I can tell, the paper does not go deeply into that part of the methodology, unfortunately. So I was not able to figure that out. But I would say that if that wasn't part of this experiment, that absolutely would be the next step, would be to give them the cardboard first. Complete blank slate. Here's some cardboard. What are you going to do?
Yeah, and then the idea that, okay, these particular birds, I mean, it's just this, Goffin's cockatoos don't make tools. And oh,
right,
look, they made tools in the lab.
Right. So do they actually make tools and we just don't know yet?
Right. Do they have certain things that they do in the wild that help them to collect insects, for instance, that we've never seen?
Or maybe they're just so well adapted to their environment that they don't need tools. Like all of a sudden in the lab, they're like, oh, I need a different beak for this. I'll have to make one out of tools. It could be out in nature. It's like, oh, everything works because I evolved over, however many thousands of years to live in this environment. I don't need any help. I'm good. But as soon as they're confronted with something it seems like they can't overcome, it's like, oh.
Yeah.
necessity.
So I
Yeah.
did
Drive
find,
some,
so they said the testing conditions were defined by the materials. So subjects that had previously made tools from the larchwood started with larchwood, but otherwise conditions were presented randomly across individuals.
Good.
So it sounds like they did a
Science.
good job of randomizing what came first. And again, this is a very small sample size. It's only about 4 animals, but it's fascinating to see it's not just one. We have a lot of spectacular parrots that we see do amazing behaviors, but it's very anecdotal. And to see this be replicated a few times definitely makes you think that this, at least this species, kind of like you were saying, we don't know if they're actually doing this in the wild or not. We haven't seen it. That doesn't mean it's not happening, but this species can make a similar shape out of several different things to solve the same problem.
Like you said, parrots, anyone who has owned a parrot or a cockatoo or even cockatiels, these birds are smart birds and they figure things out, and it's very amazing. The number of times that I've had birds escape from cages, I cannot count.
Oh, no.
Yeah.
And it was never the songbirds, let me tell you that.
So let me ask you, Kiki, is your bird cage half empty or half full?
Oh, I guess if I had one right now, I'd hope that it would be half full.
How about you, Justin? Bird cage half empty or half full?
Is that a thing you're supposed to feed on a regular basis? If so, it's empty.
This is my smooth transition way of asking you if you're an optimist or a pessimist. Are you a pessimist?
Pessimist. I really want to be an optimist. I really do, but I'm really sad right now.
I know you're segueing this, and I don't want to ruin the segue portion of it. But I am.
I did such a good job.
You did, but I am a intentional pessimist, so that I can be
Everything
optimistic with
you.
the actual results. Yeah.
Right. So
It's like going to the movie theater and assuming before you get there, oh, there's not going to be any parking. The show's going to be all sold out. We're going to have wasted the whole trip through this traffic to get there. And then when you get there and you find a parking spot and you get into the theater, everything is, wow, this is so great.
Okay, so let me put it this way. If you were a pig.
Not a bird, but a pig.
If you were a pig.
Try a different setup.
And there, in one corner of the room, there was always chocolates. And in another corner of the room, there was always raisins. And in this scenario, we'll say you really love chocolate and you hate raisins. Okay?
I was about to go right for the raisins, but okay.
So you want the chocolate, you hate raisins.
Okay.
Then a bowl shows up in the middle of the room. What do you think is in that bowl?
Gotcha. Oh, you got to check it out. Maybe it's more chocolate.
Or raisins.
It's worth checking out in hopes that it is chocolate. Yeah.
So you're an optimist.
I am.
Yeah.
I am.
So according to this test, if you were a pig, you would be an optimist. So in this new study published in Biology Letters, researchers were looking at, first of all, if pigs were particularly optimistic or pessimistic, and on top of that, if there was a influence on that behavior and opinion based on their surroundings. So humans, we know, process information that they see differently depending on their mood. They'll expect a bad outcome when facing an ambiguous situation if they're feeling negative. And if they're feeling positive, they expect a good outcome. The mood, together with your baseline personality, like whether you're generally an optimistic or pessimistic person, influences what we call their cognitive bias. Where this study becomes particularly interesting is based in the fact that many, many, many research papers where they have studied animals and their thought processes assume that most animals, if not all animals, do not have a cognitive bias. So you're seeing each individual and their thought processes as representative of a species. Now, we can probably guess
basically
what the reality there is. Yeah. is that individuals are individuals, even if they're frogs or monkeys or rats, and they process things in their brain differently. So this study put 36 domestic pigs in different situations. So they trained the pigs to recognize the bowl in one corner of the room had chocolate, the bowl in the other corner of the room had bitter coffee beans. They were coated in sugar, so the pigs couldn't sniff them out and figure out which it was before, but so they learned left corner sugar, right corner gross coffee. Then they put the bowls in more and more ambiguous spots and watched their behavior. And the animals before this were put in either an economy lodging or deluxe lodgings. Both had slotted floors, a slatted area, wooden blocks for enrichment, but the deluxe lodgings were larger and they had a deeper, comfier straw bed. Pigs with personalities that were what they considered proactive, kind of glass half full, tended to check out the middle bowl, even without being sure about whether the reward was in there or not, regardless of whether they were in the economy or the deluxe lodgings. Pigs with reactive personalities, they are allocating this as more pessimistic, were more optimistic about their chances when they had the deluxe accommodations. And they were less likely to check out the ambiguous food if they were in the economy pen.
Okay, so that's really interesting because that ties into the reevaluation of the marshmallow test that we were talking about maybe earlier this year, maybe last year, where when there's a little bit more pressure, I suppose, on survival, you take the immediate, the sure thing is you don't feel as though perhaps you can afford to take chances or wait.
Yeah, absolutely. And that also ties into the studies that we've done, I think, or reported on with rats, where if they were raised in low food scenarios, they end up fat later in life because they're always stuffing their face because they think it's going to be gone later. Yeah. So this is more saying that there are certain things that are inherent to the point where it doesn't matter how unsure you are of whether there will be a marshmallow later. If you're an optimist, you're going to wait.
Yeah. So what's interesting too, then, just to throw into this, would be really curious to see if they could redo this test and, see if at the piglet stage, they could create a little scenario where optimism
they
is
could
rewarded,
influence it. Yeah.
or optimism is not rewarded really early on, and see if later in life those pigs maintain that, because it sort of seems like these personality traits that we see later on in life could be rooted in some really elementary experiences as piglets.
Yeah,
rooted.
Absolutely.
Right?
But the bottom line is here that there are two things that affect this animal's behavior in this experiment. There is stable personality traits that they have. Those stable personality traits affect how they act, but also they have transient mood states. So this, again, ties back to tests on cognitive bias in animals and the fact that it looks really like I was saying, each individual animal is, in fact, an individual. And just one rat is not going to act like another rat. One pig is not going to act like another pig. Personality differences may affect outcomes in experiments if you're trying to test on decision-making, preferences, any of these things.
Absolutely.
And it's something that we don't have to throw a bunch of things away and start over, but it's definitely something that indicates, we talk on the show all the time about how not enough money is allocated to repeating experiments and replicating results. And this is the perfect example, is if you have an experiment that has a smaller sample size and you got one result, there's a chance that has to do with the personalities of the individuals. And so the larger sample size you have, the better, because that kind of, that rules out less of the random personality choices. helps you with your statistics. But this also means that, based on the lab that they live in, based on all sorts of
The
things
conditions,
we
do they
don't
have?
consider to be confounding variables in experiments could be affecting the personalities of our test subjects.
If two separate alien abductions took place from separate alien species and far distant flung planets, and they grabbed, say, two different people off the planet, say two different people who are, say, running for office or something, they could come away with vastly different opinions of what humans are like.
Mm-hmm.
Vastly
Absolutely.
different. One is an anecdote. Two is basically just two anecdotes. You've doubled your anecdotal size.
Yeah.
Not your sample size is not large enough to make any firm conclusions. And I'm not making any firm conclusions about this show yet. We still have so much left to go. We have the whole second half coming up. I mean, I am going to be getting out the coffee. Seriously. I will be. I hope you stay with us for more This Week in Science. Coming back in a minute.
Explain the things you heard with more than intuition.
You guys. You know what's coming? 2017. It's almost the end of the year. We are in the middle of November of 2016, and 2017 is coming. And so is Blair's calendar. So if you go to twist.org right now, you can pre-order that calendar. There's a link. You just click on the picture of Blair's Animal Corner from calendar from 2016. Click on that picture. Or there's a nice little announcement. It says, get your calendar now. And we've got a little spiel. Again, just click on the link and order your calendar. That's all you have to do. You can order them as holiday presents, for yourself, for your friends. You can order them just to give away during the year. You can order as many as you like. We got calendars, and we do hope that you order calendars because that's what we make them for, so that you can enjoy the gift of TWIS all year long. You will be kept up to date on when TWIS is broadcasting, a reminder every Wednesday. Also, science-y dates that you need to be aware of. Original artwork by Blair. So many great things, that and more. It's all very, very cool. So, twist.org. Go to twist.org. Check out the 2017 calendar and order yours today. Don't wait. Get it now. Also, if you go to twist.org, you will be able to check out our Zazzle store in the main header. So if you go to twist.org homepage, there's just a nice heading bar across the top, Zazzle store. You click on that, you'll be able to go to our Zazzle store where you will find products like hats and mugs and tote bags and all sorts of things with the TWIS logo emblazoned all over it. Also, lots of TWIS Blair's Animal Corner art from this year's calendar from the Patreon premiums from 2015. Lots of beautiful art. It's amazing. You could have a tie with Blair's T-Rex on it. There's such cool stuff available for you at the Zazzle store. So go over to twist.org if you want to get some TWIS merchandise. This is where you go. Zazzle store. Twist.org, Zazzle store. And then shop to your heart's content. Part of the proceeds goes back to TWIS. And you are also wearing an awesome TWIS thing and sharing your love of TWIS with the world or giving it as gift. You could be doing that too. If you would like to help support TWIS in other ways, we also accept donations. So you can just scroll on down on the main TWIS page, twis.org, and click on the button for Donate to TWIS. It's very easy. Click on the button, donate using PayPal, credit card. Makes it very quick and easy to donate. Additionally, at the top of the page, there is a link for Patreon. At Patreon, you will be able to donate on an ongoing fashion for at any level that you would like to. So you're able to click on a giant orange button that says become a patron, because you will be a patron of the Science Podcast Arts, helping us produce our podcasts and other things that we do every week throughout the year, all year, every year. That's what we do. If you're unable to support us that way, the best thing that you can do to help TWIS out, you want to help us out? Share us. Share TWIS with people you know. Share us on Twitter. Share us on Facebook. Share us on Snapchat. Share a picture of yourself watching or listening to TWIS on Snapchat with your friends. Take an Instagram. Snapchat. Yes. Blair, you're our resident Snapchat expert. So.
Ooh.
Yes, the many social media outlets that are out there, use them to let people know how you watch on YouTube or listen to the podcast or the radio show of This Week in Science. Share it. Get other people listening. That's going to grow us, and it's going to grow everything that we can do. So it's one of the biggest ways that you can help today, right now. Share us. We really appreciate your support, all of it in all of its forms. We could not do this without you.
The only real power that I do believe is the dollars and cents all these authors receive. If miracle wonders were held in their looks, why waste precious time and try selling their books? Why sit and wait for your publishing royalty? If one has real power, who needs reader loyalty? If you could travel by thought to a mystical place, why go to book signings and vie for shelf space? Why would you wait for your agent to call you in Venice and try to convince you?
And we are back with more This Week in Science.
Oh, yeah, we are. We're back. Justin,
I'm gonna switch up the order of the stories I was gonna bring. I switched it, and then I switched it back again, and then I can't. This story is just driving me crazy. It's too awesome. So it began 7 years ago. Divers off the coast of southern Sweden, who are no doubt just now thawing off from that dive. Gosh, that's got to be cold. They discovered the oldest known stationary fish traps in northern Europe. And stationary fish trap is sort of something that you put out there in the water, and then you come back later and hope that a bunch of fish have trapped themselves in it, right? So it's not fishing like on a hook. It's you set up some sort of thing where fish go in, but they have a hard time swimming out again. So since then, though, this is 7 years ago, since then, researchers at Lund University, Sweden, have uncovered an exceptionally well-preserved Stone Age site. They now believe the location was a lagoon environment where Mesolithic humans lived during parts of the year. Other spectacular finds include a 9,000-year-old pickaxe made out of elk antlers. The discoveries indicate mass fishing and therefore a semi-permanent settlement. As geologists, we want to recreate this area and understand how it looked. Was it warm or cold? How did the environment change over time, says Anton Hansen, PhD student, quaternary geology at Lund University. So they've done all sorts of scans of the undersea environment to sort of get the layout of what the landscape looked like, and they've sort of been rolling back water to sort of figure out how this could have looked 9,000 years ago. Changes in sea level have allowed the findings to be preserved deep below the surface of Hanö Bay in the Baltic Sea, which is sort of, if you can picture Sweden, it's the southern Sweden and a little bit to the east. If you want to fully understand how humans dispersed from Africa and their way of life, we also have to find all of their settlements. Quite a few of these are currently underwater, since sea level is higher today than during the last glaciation. Humans have always preferred coastal sites, he concludes. So here's part of why that is so interesting. This find is bigger than just another glimpse into ancient peoples. This is an ancient people that we may not really know anything else about, other than these artifacts. The people who we refer to as Europeans currently arrived or started to arrive about 6,500 years ago. So this is a 9,000-year-old site. What we call Europeans today arrived about 6,500 years ago, and they had farming. And this is sort of before the Bronze Age migration, which added a lot more people. When they got there, displaced another group of farmers who had come from the Middle East 500 years ago. So still not these people of 9,000 years ago. And those 7,500 year ago farmers displaced another group of hunter-gatherers this time, who had been there possibly about 40,000 years ago and spread throughout Europe. So that might be who these people are, but maybe not. Because by displaced in each of these cases, there seems to be very little mingling. Descendants of these populations into the next, and to the next, from what little evidence we have on record, didn't really mingle or get absorbed, but sort of pushed out. And it could have been that the environment had pushed them out just before, and then when they were gone, it allowed people to fill unused space. It's kind of unclear because we don't have the records. Of course, before this, we had, before the 40,000-year-old humans got there, there were Neanderthals there for about 400,000 years throughout Europe. And yes, Homo erectus was there about 1.8 million years ago. They left flint axes in Spain 900,000 years ago. They left 7-foot javelins in Germany 380,000 years ago. So Europe was occupied several times in different waves of people going out, different groups coming in from different directions at different times. People were displaced, replaced, and then replaced the displacers. And then there's groups that are there that we don't know where they came from. In fact, I think part of that group that we were describing as 6,500-year-old related to modern Europeans, we're really not sure where they came from. They're not directly seeming to be related to finds that we've made to the north, south, east, west, whatever, right? They sort of showed up. They're slightly related to the group that came in from the Middle East, but different genetically from the little bits of genetic info that we have. But what we don't know much about what happened to the people who made this fish trap, where they came from, and part of the reason is likely waiting to be discovered under the sea, because so much of the reason these are mysteries, where these populations came from, how they disappeared, is because where they were living is not places that are convenient to look right now. And the first thing I thought when looking at this study was the robot that they're developing, undersea robot that they're developing out of the National Aquarium, or the National Aquarium is using in Baltimore. This would be a fantastic usage. I understand they're more interested in using deep sea undersea robots to monitor wildlife and do discovery in that nature, but I think archaeology could definitely benefit from the use of undersea robots to do exploration that might be inconvenient for humans.
Absolutely. And I mean, it just makes me think so much about, looking at, if we look at the coasts and we look at where people might have lived and start looking underwater, we don't just see changes in, say, oh, here's evidence of corals that now live at higher levels in the water. There's evidence of these corals living lower in the water. So, oh, the water must have been lower. There is lots of evidence of human activity, human villages, human settlements, places that we did things, where we worked, where we fished. And I think, someday the water's going to change again, and there's going to be archaeology on the people who lived around the year 2000
in Florida,
and what we left in Florida, exactly.
Venice.
What did we leave behind? And so it's just very fascinating, to look at history that's that's not just buried beneath the ground, but is covered by water, which is constantly changing its levels.
And there's that kid who found the Clovis Point type. That after I was after the Hurricane Sandy, but it was after they had been using sand from off sea on barges to rebuild the beaches. They were transporting all this sand from a little underwater off the coast to rebuild the beachfronts. And so they apparently hit upon some sort of an archaeological site off the coast and threw up some Clovis points that somebody could just walk along the beach and find. So we've got all these sites out there. We just got to find a way to get to them.
That's right. Robots and divers. And lots and lots of coffee for the long hours. Coffee. And if you are going to be drinking coffee, how are you going to do it? You know, you want that perfect cup, right?
I just kind of pour a hunk into my coffee machine. Is that not how I'm supposed to do it?
No, Blair, let me show you how you're supposed to do it. You're supposed to do it with this equation.
Oh,
it's with math. It's with math. So
two things I love: coffee and math. Tell me more.
That's right. Some mathematicians have been modeling the math, the science of coffee extraction through water. So you have in this scenario, you have a vessel, right? You either are using something like a drip coffee maker, which has, say, a conical reservoir for the coffee, or you are using something, say, like that Justin uses, that's more of a French press or an espresso maker, where you have the coffee grounds in more of a cylindrical vessel that the water is pressurized and pushed through. And so you have these different scenarios. And not only do you maybe have pressurized water in one, or gravity feeding in the other, you also have difference in coffee grain size. So espresso grounds are often very finely ground, and coffee grounds that are used for a drip coffee maker are not so finely ground. So, oh my gosh, you've got a coffee machine maybe that you got at a yard sale. What is the best way to make coffee? Well, if you can figure out the equation that they have come up with, maybe you will figure it out. But basically what they have tried to do is to simplify all of the details. And because they said a couple of years ago, they came out with an equation and they came out with all the parameters, and it's a messy, big equation. And it's just too much. It's too many details. Right? So what they've had to do is they're trying to simplify it. It's kind of like, the E = mc squared of Einstein, trying to simplify the universe. Well, they're trying to simplify the math of coffee. So the variables they're looking at, they've got intragranular porosity, intra and intergranular porosity, coffee solid density, grain diffusion fitting coefficient, and the surface dissolution fitting coefficient. These are big phrases, right? So basically what it comes down to is they hope that this math will enable coffee machine makers and coffee makers to come together to create the optimal coffee brewing scenario. Yes, one of the authors.
I guess most greasy diners still won't.
Yeah, most likely not. But one of the study's authors said, we'd hope you could optimize the coffee machine for a certain size of grains. You could adjust the flow rate so you get the perfect extraction there.
Also, okay, here's my question.
Yes.
I feel like the perfect cup of coffee is very subjective.
I think that might be true, but I think there are aspects.
Okay, so
to it.
for example, what makes it the perfect cup of coffee mathematically? That they got as much out of the beans as they could?
Yeah. That it is an
super
efficient,
concentrated?
yeah, that it's not concentrated, but that it is an efficient extraction.
Okay.
So that the coffee that is held in the grains,
Mhm.
what you want out of it,
Mhm.
gets into the water that is filtered. So they say in the introduction to their paper, coffee is one of the most widely consumed beverages in the world. This popular drink is made from the roasted seeds of the coffee plant. Following roasting, the beans are ground and some of their soluble content is extracted by hot water. This extract is generally filtered to remove undissolved solids like other coffee grains. You don't really like the grains, the grittiness of the coffee.
Mhm.
And the resulting solution of hot water and coffee solubles is called coffee. That is science talk about coffee. Here we go.
Right.
A large number of techniques have been developed for the purposes of brewing coffee for both domestic and catering use. These methods fall into three categories generally: decoction method, infusion methods, and pressure methods. And a common feature of all these is that they're based on solid liquid extraction or leaching, and that involves the transfer of solutes from a solid to a fluid. And the target is to consistently produce the best quality coffee possible. And defining what makes a good cup of coffee is a non-trivial matter, and to some extent, a matter of personal preference.
Yeah. There you go.
And so it was surprising to me to find that in this paper they referenced coffee is composed of over 1,800 different chemical compounds.
What?
1,800, more than
Save
chemical
your
compounds.
caffeine.
Yeah, and then other things.
You're right.
So
I lost track after that. That was all I had. Caffeine molecule.
But all of them fit into the flavor and the personality of your coffee.
Wow. Well,
Yeah.
I mean, sometimes there's hazelnutty things in there, and I'm not into that at all. So
Yeah.
those hazelnut molecules can get the heck out.
Yeah. Yeah. So, there are some people who like more bitter coffee. Some people like a sweeter coffee or a more rounded flavor. Most people can agree on brew strength, I think, but there's also the strength. Do you like diner coffee?
Given
I
one
kinda
option,
do.
Coffee.
given one option in the morning, I will drink just about any kind of coffee.
Yeah.
Yeah. So the paper is available online at SIAM, the Society for Industrial and Applied Mathematics. It's very math and coffee together.
I still think
Not
the equation for making a good cup of coffee should be shorter than, explaining how gravity works.
Very probably, yeah.
Getting us to the moon with FMA should have been a bigger. Maybe that one should have just been a bigger equation to me. But,
My question, if I were to interview these mathematicians, would be, and how much coffee did it take for you to write this paper?
None at all. I don't know what you're talking. I don't drink any coffee. I never touch this stuff.
Yeah.
I wrote the paper in 2 days. That was a long time. I almost slept 15 minutes one night. I was exhausted.
All right, Justin, tell me a story.
Antibiotic overuse and general human sloppy germ swapping have created a crisis of resistance to treatments of a wide variety of infections that once were held in harmless check. Most antibiotics in use today are based on natural molecules produced by bacteria. Yet apparently coaxing bacteria to produce new antibiotics is tricky. Most bacteria won't grow in the lab, and even when they do, most of the genes that cause them to churn out molecules with antibiotic properties don't really get switched on. And because of this, we have a hard time fabricating or manufacturing new antibiotics to replace those that are losing their efficiency. Recently, researchers at Rockefeller University found a way around this problem by using computational methods to identify which genes in the microbe's genome ought to produce antibiotic compounds. Then they went about synthesizing the compounds themselves instead of doing the whole petri dish thing and letting them go. And they were able to discover 2 promising new antibiotics without having to culture a single petri dish. Even though the picture that they used to headline the article shows a petri dish. They then used specialized computer software to scan hundreds of those genomes for clusters of genes that were likely to produce molecules known as non-ribosomal peptides, form the basis of many antibiotics. They also used the software to predict the chemical structures of the molecules that the gene clusters ought to produce. Research identified 57 potential useful gene clusters, when which researchers then narrowed down to 30. They then used a method called solid phase peptide synthesis to manufacture 25 different chemical compounds. By testing those compounds against human pathogens, researchers successfully identified 2 closely related antibiotics, which they dubbed Humicin A and Humicin B. Both are found in a family of bacteria called Rhododokus microbes that have never yielded anything resembling the humimicines when cultured using the traditional laboratory techniques. So the humicines proved especially effective against Staphylococcus and Streptococcus bacteria, which can cause dangerous infections in humans, tend to grow resistant to various antibiotics that we already have on the market. Further experiments suggest the humimicines, I'm not going to get it right, work by inhibiting the enzyme that the bacteria use to build their cell walls. And once that cell wall building pathway is interrupted, the bacteria die. This is something, a similar antibiotic that we use or works, or similar way it works, something called beta-lactams, which is a broad class of commonly prescribed antibiotics that's losing its efficacy, its efficiency over time right now. There's a lot of things resisting it. But the scientists did find that using
Humimicins?
Humimicines, I think that's it. Humimicines could be used to resensitize bacteria to beta-lactams that had previously lost their ability to work. One experiment exposed beta-lactam-resistant Staphylococcus microbes to humimicin A in combination with beta-lactam antibiotic, and once again, it was effective. Now, humimicin A by itself wasn't really that effective, but the 2 in combination suddenly worked with where neither of them really were going to work on their own. Sean Bradley, head of the Laboratory of Genetically Encoded Small Molecules, attributes this to the fact that both compounds work by interrupting different steps in the same biological pathway. He says, it's like taking a hose and pinching it in 2 spots. Even if neither kink halts the flow altogether on its own, eventually no more water comes through. And while that's a terrible analogy, because that's not how hoses really work, Bradley still hopes that the discovery will inspire scientists to mine the genomes of bacteria for more molecules that could yield similarly useful results. Yeah, and there's a summary that, so this was a bacteria that he was grabbing in the first place to do this, came from the human gut already. So it's sort of interesting, you're looking for something that's already in the gut, so that perhaps the molecules that you're going to create from this won't be too disastrous to the surroundings. Although, I guess in the way that they manufactured it, it doesn't matter that it originally came from the human gut, because it's something that microbe or that bacteria in the human gut doesn't normally produce. So.
Well, it's not that it doesn't. It's not that it doesn't normally produce it. It's that in the laboratory they'd never found it before. So it just means that in laboratory conditions they'd never gotten them to produce it before. It's not that they don't produce it in the gut. It's just that lab conditions weren't conducive to the production of it. And so what they've done is changed their methodology. And by doing this new methodology of this assay, they've basically found something that they overlooked previously because the technology was different.
Yeah. So, but it may also be that even if it is producing it, it may not be producing it, certainly not enough quantities to actually be giving us.
Maybe not large quantities, right?
So this is sort of a new way of going about it. You look at the genome, you see what the body is capable of producing, or what bacteria in the body are capable of producing. You produce it yourself based on computational descriptions of how that should look. I mean, they're really going into they're going in sort of like, okay, bacteria, I know you have potential. You haven't been living up to it yourself, but I can see it, and I'm going to go ahead and do it for you. I'm going to help you out here. And he's now saying this method he can do on bacterial species that aren't in the human microbiome already, and once more and more things get sequenced, they can keep applying this search.
Yeah, I think the other aspect to it also is the excitement of finding these new things. And we've reported on some other potential antibacterial agents that have been found through other bacteria, not from people, but from just other bacteria that were isolated, where they cause this renewed sensitivity with antibiotics that are waning in how they work. So that's the other exciting thing. It's like, oh, we've got these antibiotics that aren't working very well anymore because of antibiotic resistance, but you couple it with something like this, and it's like, bam, bam.
Suddenly it works.
Taking everything down all over again. Yeah. Mm-hmm. Which is great. It's great. Does it tickle you?
And it's very tickled by this.
Are you very tickled by it?
Mm-hmm. I'm not ticklish.
That's not true. You've got to be ticklish. You're ticklish. I can be ticklish or not ticklish. I got tickled a lot as a child, and so I learned to concentrate so that I would not be tickled and won't laugh. So if I don't want to be tickled, I'm not ticklish. But if I want to be tickled, then it's okay. But question is, what controls all this ticklishness or not ticklishness?
The silly center of your brain.
Yeah, well, that silly center is maybe otherwise known as the somatosensory cortex, or at least a certain part of it. And how do we know this? Researchers tickled rats. Oh. That's right.
With their fingers?
They tickled them with their fingers.
No!
Yes, they tickled rats. They tickled them on the belly. They tickled them and made the rats laugh. And so you've brought up in the animal corner before, we've talked about these ultrasound kind of little shrieks that mice and rats give off that aren't the same as the ones that we hear. It's higher pitched than that.
We had the singing mouse on here.
Right, singing mice. Well, these are laughing rats. And they giggle. And the researchers, Michael Brecht at Humboldt University of Berlin, Germany, says it's remarkable, the similarities between rats and humans, the fact they vocalize and clearly enjoy tickling so much. So Brecht's team, they did stick electrodes into the somatosensory cortex, which is part of the brain that is important for touch, for your skin. So when you feel your shirt on your arm, that is because there's a nerve that has a receptor that's been stimulated in your skin that sent a nerve signal up to your somatosensory cortex where you can perceive it. So anyway, they put electrodes in there to measure what was going on, and they found that tickling activates part of the somatosensory cortex. And they also found that rats like being tickled on their feet too. Yeah. They additionally found, they did another test where they put the rats in a very stressful situation. So rats are nocturnal. They put rats in a very open cage and with a bright light shining on them. And they found that rats aren't ticklish then. Their tickle cells become less activated. And they're not as tickleable when they're stressed out. And so there is some aspect of stress or mood that moderates ticklishness.
Wow.
In rats.
Love that.
And then in another part, they found that the cells become active right before tickling starts. So it's like if an animal learns that tickling is going to happen, those cells respond and there's an anticipation. And they believe, based on this and some other activities they did
Psychic
with the
rats.
not
Psychic rats.
they some other activities they did where they had the rats chase the researcher's hand after they got tickled. So they basically they tickled the rats and then had them chase for more. And they linked it with play. And so Brecht says that it's possible that it might be a trick by the brain to encourage sociality and playfulness. And so there could be an evolutionary role of tickling that he says the tickle response is profoundly social, aimed at others and not yourself. And this is very likely why you can't tickle yourself, is in that it is not a self-oriented behavior. It is an outwardly oriented social behavior.
Interesting.
Yeah. Tickling in rats. I want to be a rat tickle researcher. What did you do? Tickle rats for a living.
A rat tickler.
Goodness.
I'm a rat
It's a
tickler.
booming industry right now. I'm riding the crest of the wave as a top of my game right now.
Is that better than being a bird poop researcher, Kiki?
Possibly. Very possibly. Yeah. So anyway.
That no relation, but I was we had the book fair thing where they make you buy books and mostly junk books for your kids at the school. It's their fundraiser event, but they bring all the kids in there to do walkthroughs of all this stuff. And then the next day, the kid, right after school, drags you over there, having already picked out like 10 things they want to buy. But there was a book up there that I got really excited about because I wasn't wearing my glasses, and I thought it said animal feces. And I'm like, oh, that's so rad. There's a whole book on animal feces, but it was animal faces. It turned out it was. I was like, oh, we're getting that one right there. A whole book about animal poop. This would be fantastic. But
well, don't we have some animal feces in our quick rundown?
That's right. You tried to toss to the bird poop. Yes, and I didn't jump on it quickly enough. But yes, animal feces, bird poop. I'm bringing it right back around to the end of the world, where I started at the beginning of the show. It was reported in Nature Communications, that birds poop a lot on the rocks in the Arctic. And that ammonia enriched poop, the guano, has a slight cooling effect on the atmosphere. I'm going to just say it right now, not enough to really counteract the warming effect that is going on currently. But this is such a fascinating process because it is so enriched with ammonia. The emissions of ammonia from guano, when the poop is in the sun in the summertime on these Arctic rocks, it is released. Little bursts of ammonia go into the atmosphere, and the ammonia interacts with sulfuric acid and water, and it forms particles that become the nuclei that give birth to clouds. Cloud forming, ammonia-rich bird guano. It's amazing. So anyway, clouds, if there's a lot of clouds, play a role in reflecting sunlight or heat. from the
I
Earth.
thought you were going to say that it had to do with albedo, that all of the poop was somehow affecting the reflectivity.
Well, it's
But
cloud
no.
reflectivity.
Yeah.
Yeah,
Fascinating.
and they said it actually is that's enough. It's complicated, but it's these low-lying clouds that get formed actually really have a cooling effect on the region and across the Arctic. It's significant. So ammonia.
So
from bird
keep
poop.
pooping, everybody. Don't stop.
Right? Birds
Puffins, don't stop.
keep going to the Arctic and doing things in the Arctic. That we want that. Come on. Yeah.
Birds, you do what you do best.
Oh, I love the birds. All right, Blair, tell us some bat news.
Yeah. So we have a new world record holder for the fastest horizontal flight. And it is no longer a bird. It is the Brazilian free-tailed bat. So the previous record holder was the common swift, which can reach speeds of over 100 kilometers per hour. These little bats, believe it or not, can go 160 kilometers per hour. That is about 100 miles per hour for those of us in America.
That's fast.
Yeah, that's very fast. Now, at first I went, that's not the fastest thing, but there are different qualifiers here. So this is the fastest horizontal flight. The fastest thing on the planet is the peregrine falcon, which reaches diving speeds of about 300 kilometers per hour. That's about 185 miles per hour. So that's the fastest animal overall.
How fast is a person in a squirrel suit diving down a cliff?
The speed of gravity. I don't know.
Right.
Anyway, yeah. So this little bat they found from an Max Planck Institute did the research and found that these guys are now the fastest. They're these little 12-gram bats, the Brazilian free-tailed bat, now the fastest horizontal flyer. And what's that?
Faster than swifts.
Faster than swifts. Yes, the bats have outflown the birds in this specific case, which is kind of unusual because bats are thought to be not super aerodynamic as compared to birds. But these guys are just doing a great job.
Catching the moths.
Yeah.
Flying so fast.
And then my other real short story is an awesome finding out of Japan and Russia. And that is that there are snails that don't use their shells for what we're used to. They found 2 species of snails that use their shells to attack predators. They don't hide in the shell. They whack their predators with their shell. And you have to see this video to believe it. Whacking. So I'm hoping that Kiki can share this.
The predator whacking snails.
Yes. These 2 snail species, Caraftohelix gaiense in Japan and Caraftohelix selski in the Far East region of Russia, swing their shells to hit the carapid beetles, demonstrating a unique active defense strategy, while other closely related snail species withdraw their soft bodies into their shells. So watch them go. Can you believe? Yeah. I could not believe the range on this snail. So for those of you who are only listening, I strongly suggest you go to www.twis.org, click on our show notes from tonight, and watch this video because it is fascinating. Even more interesting, as far as they can tell, these snails, if you trace them back to a common ancestor, that ancestor does not whack its enemies with its shell, which means most likely this is a convergent evolution trait. So this is something that has evolved twice so far that we have found in the snail realm.
And very useful, obviously.
Yeah. I know, the beetle definitely got the heck out of there when he was doing it.
I got upside down and then I got pushed out of the way. I don't like that.
Yeah, it's like taking off your football helmet and just smacking a linebacker with it.
Totally. That's not allowed in the rules.
No.
That and you would immediately regret having removed your helmet
Right. Exactly.
to do that.
Yeah. My final story. This is we've talked about the over-the-counter homeopathic drugs being reviewed by the FTC, and they held a panel, a workshop last year, and they have released their report from that session, as well as come up with a final ruling as to how homeopathic drugs are to be marketed and sold if they're over the counter. And the policy statement notes, quote, the FTC has long recognized that marketing claims may include additional explanatory information to prevent the claims from being misleading. Accordingly, it recognizes that an OTC homeopathic drug claim that is not substantiated by competent and reliable scientific evidence might not be deceptive if the advertisement or label where it appears effectively communicates that, one, there is no scientific evidence that the product works, and two, that the product's claims are based only on theories of homeopathy from the 1700s that are not accepted by most modern medical experts.
Would really the 1700s be in there? Like that would be,
yeah,
that would be awesome.
In the packaging. This cures the common cold, according to stuff we did in the 1700s, or when people died a lot from the
You guys, I'm
common
not
cold.
feeling bad. Great. I'm going to go pick up some leeches. I'll be right back.
Yeah, so
Actually, those probably will work better than anything you ingest.
leeches are scientifically proven and actually used in medical treatments these days.
Oh, right.
Anyway, the FTC has basically said that the marketing of these drugs cannot be different from any other over-the-counter drugs, and that they are going to scrutinize the impression of these marketing claims, and if an ad conveys more substantiation than a marketer has, it's going to violate the FTC Act, and they will be penalized. So, yes, from now on, homeopathic treatments must say that they don't work, or that they don't have any proof, or they can't make any claims about their efficacy.
That is
Oh,
a great step in the right direction.
It's a win for science and for public health in the United States. Good job, FTC. You voted scientifically. Yeah. And that brings us to the end of our show. It's so great. I know Fada had mentioned on Twitter that we had talked previously about the Project Blue Space Telescope, in which they're going to try and crowdfund the funds to create this coffee table sized telescope to be launched, and their crowdfunding campaign has begun. So if you're interested in that, I would go look for Project Blue Space Telescope. Otherwise, it's the end of the show.
As we know it.
Yeah, it is. And I would like to take this opportunity to thank our Patreon sponsors. Thank you, Chris Clark, Paul Disney, G. Burton Lattimore, John Ratnaswamy, Richard Onimus, Byron Lee, E.O., Jared Lysette, Ulysses Adkins, Kevin Parachan, Andy, Keith Corsell, Jake Jones, Dave Friedel, Mike McGraw, James Randall, Eric Schwalb, Bob Calder, Mark Mazzaros, Ed Dyer, Trainer84, Brian Hedrick, Layla, Marshall Clark, Charlene Henry, Don Kamarechka, Larry Garcia, Randy Mazuka, Tony Steele, Steve DeBell, Harun Sarang, Melissa Mosley, Alex Wilson, Jason Schneiderman, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Richard Porter, Daryl Lambert, Rodney, David Wiley, Robert Aston, Rudy Garcia, Nick Abassi, Felix Alvarez, Darwin Hannon, Cosmic Gypsy, Brian Hone, Orly Radio, Brian Condren, Pixelfly, Marked, Nathan Greco, Hexator, Deborah Smith, Mitch Neves, Flying Out, John Crocker, Christopher Dreyer, Ben Rothig, Sylvan Westby, Artyom, Shu Wada, Dave Wilkinson, Steve Mashinsky, Rick Ramus, Gary Swinsberg, Phil Nadeau, Braxton Howard, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Insom, Michael George, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, John Maloney, Jason Olds, James Paul West, Alec Doty, Illuma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, David Simmerly, Tyler Harrison, Columbo Ahmed. Thank you for your support on Patreon. And thank you to all our new Patreon supporters. I saw some new names in there. Thank you so much for your support.
Yeah. Welcome to the family.
That's right. And if anyone out there is interested in supporting us, you can find information at patreon.com/thisweekinscience. Also, remember that you can help us out simply by telling your friends about TWIS. That's right. Those social medias, use them for TWIS. And on next week's show, we will be joined by author, science writer Eric Vance. He has written a book called Suggestible You. And it's all about the ways our minds play tricks on us, depending on various states of our body or brain. So it's going to be a fascinating interview. He has put himself through the ringer on various accounts. And so it'll be great to speak with him. And once again, we're going to be broadcasting live online at 8 p.m. Pacific time on twis.org/live. You can watch live, join our chat room. Hey, chat room, how you doing? Love scrolling through the chat room during the show, seeing what people have to say. But, you know, if you can't make it, you can find our past episodes at twis.org/YouTube, or just go to twis.org.
Yeah. Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile device, you can look for TWIS, the number 4 droid, Marketplace, or simply This Week in Science in anything Apple Marketplacey.
For more information on anything you may have heard here today, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts as well as other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from today's show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
All right.
You guys, I'm going to
What
say
happened?
it one more time.
Oh.
Order your calendars. Please.
Don't
Get
forget.
your calendars. Don't
Christmas
forget.
is coming. Get them before Christmas.
Get them before Christmas.
Please.
Get them before Hanukkah. Get them before whatever. Get them before New Year's Day. Okay?
You know what I want for my birthday this year?
Twist.org.
To sell out of calendars before Christmas.
Oh, and what day is your birthday, Blair?
December 12th.
That's right, December. So before
So-
December 12th, let's do it. We've got less than a month to sell out. We can do it.
That's right.
Do it.
Yeah, so do it by my birthday.
Your birthday,
Yeah.
the 11th.
The 11th.
Right. So crazy. My co-hosts born a day apart from each other. This is my
What's this
awesome.
one day that separates the birth of Justin and the birth of Blair. Just one day.
And they couldn't be more different. Well, one day and several years.
Oh, anyway, what were we talking about? Oh yeah, also in stuff that we talk about when we're doing an after show. There's other stuff. You know what? I'm gonna go. I think I have to leave. I have to go to find somewhere to sign up to be an archaeologist. I think I got to do that. Like, I want to go investigate these the ancient European before the ancient Europeans, but after the Neanderthal peoples. I'm like fascinated that we don't really know anything about them, but that they were everywhere.
That's pretty cool.
Yeah. And plus it's like, you can pick archaeology, things to specialize in. Specializing in an archaeology that's all over Europe would be pretty awesome. You would be traveling Europe constantly. Where are you going? I've got to go to work. Where are you going? Ireland,
Far away.
Sweden, Germany. I got to
Someplace.
go to France and Spain the following weeks. Look at some sites. It's a drag. I got to keep this Eurorail pass. Yeah, I'm always on the move. That seems like the kind of archaeology to get into. Something like that. Not something really super rurally frozen. You don't want to do Arctic archaeology. You don't want to do desert archaeology. These are tough gigs, just in general. A lot of the times these dinosaur researchers are going to really awful deserts to find things. I think that's a terrible way to live. Glad that there's people doing it, of course, but
Totally. Oh, you guys. Eric Verlinde has a new paper out. Theory of Gravity. You're going to love this one, Justin. We've talked about Verlinde and De Hooft and other Gerard De Hooft and the holographic principle and stuff.
You're a dehoofed.
De Hooft. So Verlinde has his paper is on the archive preprint server, and it basically is on the idea of emergent gravity, so not as gravity as a force as some say that it is.
Yeah.
So it would not have a particle of its own, but actually that it is it's not fundamental, but an emergent phenomenon. So,
of space.
along with this, he concludes the result. He has like dark matter tied into it as well. So, this is going to be interesting. I got to check this out. I do like Verlin's ideas. He puts strange ideas out there. But as far as I knew, 't Hooft and Verlinde were, other people came out with papers saying there's no way that they were right. But although, yeah. Let's see. In 2010.
And it gets rid of the need. And you don't need dark matter.
You don't need dark matter. That's what it is. Yeah. Yeah. So basically, with his idea, you don't need dark matter. No extra particle.
And I think we vaguely covered this a week ago.
Yeah, well, we have covered it before because he and 't Hooft have published various papers on the holographic principle throughout the years.
But very recently, like a week ago, we were talking about how they did the measurement of the spin and how the dark matter.
Oh yeah, it was in
the right rate for the amount of observable matter there.
Yeah, it was like in different star systems, right?
Yeah.
Yeah. Yeah. It's fascinating. Yeah, he says, whereas ordinary gravity can be encoded using the information on the imaginary sphere around the universe, which he showed in his 2010 work on the holographic principle, the result of the additional information in the bulk of space is a force that nicely matches that attributed to dark matter. Mm-hmm. Part of the information in our universe is contained in space itself, not just the information being on a giant imaginary sphere around the space we're in. I love this idea that we live in a hologram. So crazy. So the idea it's like there's a sphere with all the information on it, and there's like this, because of the information, there's a hologram that's projected that emerges from all that information, and that's where we live in space. And then this idea kind of says, oh, there's some information in space also. And that takes care of dark matter. So I don't know. It could be a just so story, though. Don't we have other proofs for dark matter? Yes and no. Yes and no. We definitely have. Evidence of mass. And we've got the big evidence that everybody goes back to is the evidence of systems passing through each other. So you have galaxies passing through each other, and one passes away, but you still have like a bulk of mass that gets left behind, even though there's no actual matter visible matter that we can see there anymore. And so it's
right, but
said to be dark matter.
But that mass could be dark matter, or it could be that we're just talking about a warpage of space.
It is exactly. Yeah.
Be stuff there, and they've got what is it, the sterile neutrinos that they've been looking for, and they built a detector for, and they found nothing so far, which was supposed to be an indicator of dark matter. So experimentally, when we've looked for it, but it's not the first time it took us a long time to find something, but experimentally we've not been able to detect or prove that it exists.
Yeah.
And so as long as there is other possibility out there, should be being looked into. And he's been on this for a while, and I like it. I like it better than I've never understood the graviton. Not that
I
I
don't
understand anything
understand the
really in physics.
graviton either. It doesn't, we really
But it
don't have
just seems
proof
to
of a
like
graviton. Everybody's like, there's a
cheat, and it
graviton. And it's like,
cheats.
what?
And then it leaves our dimension, and that's why it doesn't have an effect here. And they're generated continuously, and they have to react to
I don't know. There are a lot of
everything
weird
all
things
over the
in
place faster than the
universe.
speed of light continually. And it's a lot of stuff out there for something that you, had to make up.
Yeah. I don't know. Yeah, I am intrigued. I don't know enough about any of it to know. And of course, nobody knows for sure. But this is I find the holographic principle and Verlin's ideas intriguing, to say the least.
I don't like the holographic thing, though. That makes me feel hollow inside.
Oh, it's all still real. I mean, it's information. Come on, it's all good.
Yeah.
It's all real.
Like
We're real. We're real little bouncing bits of information.
Yeah, everything is eventually. If you look at it.
Yeah. Super fun stuff. There were so many stories I did not end up talking about this week. Did you guys have that problem this week?
This week was a very rich science week.
Last week I was like, I don't know, I don't care. There's nothing I like. And this week I'm like, oh my goodness,
Too much.
so much
Actually,
stuff.
I found this one in the 11th hour and didn't have time for it. But world's smallest magnifying glass makes it possible to see chemical bonds between atoms.
Nice.
Huh? What? Cray. Could have an augmented self as well. Which one am I? Am I the real me, or am I what do you call it? The avatar. Oh, wait.
There was Pluto news. There might be a water ice ocean lying underneath Pluto's heart.
Water, ice, ocean?
Yes, slushy ocean of water ice. So probably very salty, and could be a subsurface ocean. Astronomers have observed that Tombaugh Regio, Pluto's brightest region, aligns almost exactly opposite the dwarf's planet moon Charon in a locked orientation. It hasn't had a very convincing explanation. And a heavy ocean would have been a gravitational anomaly, they say, or weight that would have factored in Pluto and Charon's gravitational tug of war. And that it would have allowed the planet to kind of wobble until it spun around and aligned with Charon directly. But then additionally, the heart is where it is because of some kind of giant impact at some point. Published in Nature, researchers looking at the heart-shaped region again say that that it could be where this heart could be where it is because of accumulation of ice. Because accumulation of ice made the dwarf planet roll over, creating cracks and tensions in the crust that point towards the presence of a subsurface ocean. So those are similar, but that basically ice on the surface also added to the weight on the surface of the planet that got the planet to roll over and spin and orient itself. And then the subsurface ocean added in there. And then it's like, oh, its heart's gonna point at Charon forever. Little ball of rock. Oh, here's a cute animation. You guys want to see an animation?
Always.
We always like animations, right? There we go. So we have past coming forward. Ooh, volatiles growing. That means ice on the surface. That's what they mean. Bloop. Look at that spin that happened. Sharon just sat there and watched it. And shot an arrow through Pluto's heart.
How dare you?
Yeah, I think it's interesting. It didn't. I love that wasn't always where it is now. It moved. Why did it move? How did it move? Like Earth, we had our giant impact that set the moon and the Earth kind of where they were. We talked about that. They did a little dance to make the Earth used to be super tilted and the moon kind of pulled it back up. And then this kind of thing happened with Sharon and Pluto. Fascinating. That's another story I can get rid of. Yay. There's so much stories this week, you guys. So much stories. I'm sure that Ed is going to talk about a lot of them tomorrow. I'm sure. This is cool. Work presented at the Society for Neuroscience meeting this week by Nick Ramsey from the Brain Center Rudolf Magnus at UMC Utrecht in the Netherlands. There's a paper coming out in the New England Journal of Medicine where he's got a patient who with ALS, which is otherwise known as Lou Gehrig's disease or motor neuron disease that destroys neurons required for voluntary muscle control. Her body doesn't work anymore. She has control of her eyes, but that is it. They implanted a brain control interface into her brain, an electrocorticograph, and the electrical sensors are inside the skull against the brain and can read brain activity. And the patient learned how to use the implant basically to perform a brain click, to be able to like basically click a mouse clicker. And so now instead of using eye tracking as an input method, she can communicate when her eye track computer doesn't work with her brain. Nice. The power of her brain. Is ALS the same thing that Stephen Hawking has? Is that the same?
I don't know.
Yeah. Anyway, this is the first person to use a fully implanted brain-computer interface at home in day-to-day life without constant doctor supervision. It's pretty cool. Taking it home, not in a lab. It's awesome.
Did you know that in London you can take a rainbow unicorn to work?
Wait, what?
Yeah.
Explain, please.
Unicorn-drawn carriages have just been launched in London.
Because why not?
Yeah. 2 horses decked with rainbow manes and horns draw a white coach complete with rainbow pattern on the side. Dressed in purple suits and yellow shirts, crowned with top hats, the coachmen don't fall behind either. So-called unicabs are a temporary thing brought in to cheer Londoners up as the mornings get darker, they say.
That's funny. Cheer up, London. We know it's getting dark, but here's a rainbow. A unicorn rainbow.
And they're absolutely free. That is hilarious. Oh my gosh. I love it.
You can ride a free rainbow?
Free rainbow unicorn unicab. You just have to tweet at the British phone company. 3. And you have to tweet at 3UK the station you'd like to be picked up from, your destination, and the hashtag magic together. I love that.
Because really, if you're riding a rainbow unicorn cab, that is magic you're having together with the rest of London. It's awesome.
Oh, that's great.
I'm sleepy, you guys.
I'm real sleepy.
Yeah. We have a calendar done. Thank you for doing that, Blair. Really appreciate
Yay!
it. And
We
thanks
did
to
it.
Patrick for helping with the art on that.
Yay!
Yay. All done. It's ordered. Calendars will be coming if you order them too. Yeah. Anything else? Oh yeah, we're still thinking about January 19th. I haven't heard anything yet.
Okay.
For the
I know
SF
the
Sketch
lineup's
Fest.
getting released on Friday, I think.
Yeah, I was told when they emailed me, they said it would be like last week, but it wasn't. So,
Yeah.
So
I
we'll
got an
find out
email
later.
because I get Sketchfest emails because I love Sketchfest, saying that they would announce the lineup to the general public on Friday the 18th.
Awesome.
Cool.
Yeah.
And I guess
8
that
we'll
means
have.
we either aren't in it or
No.
We
that,
are in it.
we're
40 minutes
the
of
general
fun. 40 minutes of fun. It's a little shorter than a normal show. So we'll have to do a regular show and then do that the next night just for fun. It'll be a just for fun episode of TWIS.
Just for fun.
Yeah. It'll be good. It'll be great.
I'm looking forward to it.
Oh yeah, Genescu, where is my wine? It is not even close to halfway, so it's on its way to empty. Tonight was a wine night. I work very hard at not drinking on show nights, but lately I've decided I didn't just do what I want.
Lately, some of those things have gone out the window.
I don't care anymore. I'm gonna do what I want.
But they're unicorn cabs.
I know. Oh, did you guys see my post about the Post-it notes at Kai's school?
I saw it. I don't remember what it said.
So at Kai's school, he's in kindergarten, but it's a K through 6th grade elementary school. And this Monday, when they returned to school, last week was they were out of school all week, so they hadn't. It was the first time they'd come back to school since the election, and they showed up at school. And in the morning, every single locker, 500 lockers for one for every kid. Every kid has a locker in the school. Each locker in the school had a Post-it note, a nice colorful Post-it note with a message like, "You are loved. We appreciate you. Thank you for being here." Like all these messages of affirmation and just positivity. And like today I picked Kai up and he was wearing his, like he'd left it on his locker for a few days, but like he was wearing his on his shirt today on the way home. Like I think it really touched the kids, and it was just such a wonderful thing that some of the parents did that I think is just fabulous. And yeah, I'm going to give Post-its to people. Post-its. Post your love. Post it. You know what, you guys?
What?
You are loved.
You're
I appreciate
loved.
you.
Aw.
And I am looking forward to our, what is it, TWIS Giving episode? next week. Yeah, pre-turkey madness. Or for vegetarians, pre-tofurkey madness. The night before your stomach was so full.
Let's fill your head with science
We will.
before we fill your tummies with turkey.
That's right. That's what we're gonna do. Can't wait. It's gonna be great. Oh, Whiskey Renegade, shush. The stickers were all fine. Yeah. I think I'm ready to go to bed. You guys got anything
I'm
more?
so ready. I'm exhausted.
Good night, minions. Good night, Kiki and Blair.
Night.
I'll see you next week.
Thank you so much, everybody, for watching. Thanks for being with us tonight.